VPick and VPack are material handling products for palletizing and depalletizing boxes onto pallets. Incredibly difficult to do perfectly every single time.
Is one box actually two boxes, or is it a half of a box? We've had to develop entirely new techniques to even try and approach this problem.
We're doing a full vision package, including our software, which we write all of the algorithms in-house. Takes a lot of that engineering upfront cost out. We can sell that full system, and it brings a lot of value to customers.
VPick is picking off of a pallet. It's depalletizing, where we have no idea what's on the pallet and we're able to pick it off.
You can have the pallet be shifted around, so your part now has moved. You could have damage to some of the case edges, open seam boxes, glued flaps, a variety of different things that would be challenging for a traditional vision system. So the solution with Liberty Robotics allows us to pick agnostic product, unknown SKU, and be able to pick it with certainty and reliability. In order to optimize the fill of a large ASR system, you want to optimize the space in which you're filling those totes. So this solution allows us to pick the correct number of boxes with the minimal amount of tries to be able to optimize the space on the first pick.
It's insufficient that we make a mistake every 1,000 cycles. We have to instead operate at a level of robustness that's somewhere around making one mistake every 100,000 to one mistake every million cycles. We don't just try to identify a single box. In unloading problems, we have to identify all the boxes that are sitting there in order to efficiently understand how to interact with all those boxes. In the VPick product, we attack the problem using a hybrid classical image processing plus deep learning set of technologies.
It's our software that sets us apart from everyone else. Customers oftentimes have a great understanding of what we do with our software. And if they don't, they come here for one day of training and they get a good understanding just after one 8-hour day.
We make the user interface easy to use so that you're not relearning our product every time you step back onto using it, even if you've had to step away from it for like 6 months.
It's got a really modern tab-based look and feel to it. It's super intuitive to use. So you want really good fault handling, error messages. The system has all of that, including deep parameterization and stuff. So you can do settings per style, per sensor, and we have a 24/7 support hotline. Customers can call us at any time. We answer those phone calls at any hour for our customers, no matter what.
We're nimble, all the way from our research down to the engineering side. Many times we have customers that come back to us and they're asking us for various features, enhancements, and we're able to very quickly implement those.
VPack will take that box that's just on some conveyor, some table, and it'll go one by one through the boxes and calculate the ideal put positions for each box to minimize the wasted space on the final filled pallet.
You have to build what's called a shippable pallet, meaning that pallet has to be stable. Fill volume has to be high. When a random case comes down, you got to figure out where the best place to put it is so that when the next one comes, you're leaving enough space for it if it's a bigger box or a smaller box. We also do carrier loading, containers or boxes or parcels into carriers. It's typically a ULD that goes onto an airplane and stuff like that.
The sensor that's mounted over top of the conveyor is taking a snapshot of that package, feeds that information to the software. Software then figures out best placement. We do palletize 3 different locations in this case. Right now we're only palletizing 1 for the demonstration, but tell me which pallet I need to go to, and then it'll select the best fitment. Once it places a carton, the robot will retract, and if it's overhead sensor, like what's over position 1, that overhead sensor will do its work, which is taking the global image of the world model, or the robot mounted sensor, which is this here. When the robot retracts, it'll take that image and then it'll update the world model and say, okay, now I know I placed that package, it's in the right place, and then it also plans for the next package ahead. Cartons per hour really draw the bottom line for return on investment. The goal is to make sure that these joints are moving at all times, so that way that robot's paying for itself. The most exciting thing is the fact that we are picking on first sight and placing, so there isn't any upstream knowledge of any of the packages coming our way. You can go in unintegrated if you want to, so it could be a standalone system. They don't necessarily have to have a massive infrastructure ahead of it, which allows a lower barrier to entry. It's truly a product. It's not necessarily a customized or one-off solution. It's something that I know that I can sell without changing anything. We get along great with the Liberty team. It's always been a pleasurable experience building it together and then really bringing something to market that we can all be proud of. I think that that's a great thing, and it's really a fun thing to be a part of.